Army presents The Big Picture, an official report produced for the armed forces and the American people.
The time is now. And in Florida, a mighty Jupiter thunders into the sky. The East Coast, a signal is bounced off the moon. The West Coast, research paves the way for the first astronaut. New Jersey, the nose cone of a new missile takes a simulated ride through space. Maryland, research on the cause and prevention of respiratory diseases. Mississippi, plans are made to prevent a flood. And in New Mexico, each new day brings a giant dam closer to reality. What is the connection webbing together all these activities? The answer, the United States Army. And in this special television report to the nation, coming to you live and on film, we will present the United States Army science story. In just a moment, immediately after this announcement, a story that's taken our TV reporters through the length and breadth of America to do research at Army technical centers where scientific breakthroughs are made every day, every week in...
Well, that's the opening for the show. What do you think?
Good opening.
The rest is good, too.
Well, if it's so good, then why do you want to change it?
I want to focus it more on the men involved. I mean, well, the achievements are exciting, breathtaking. But what about the men who are doing the job? What are they like? What breed of cat are they?
Mm-hmm.
Now, the place for it, I think, is right at the beginning. Right after the opening, we saw... Hello? Oh, good. Let's have the lab knock off another print right away. That so? Excuse me.
In the office of a large television network, one often finds the team of young producer and aging writer. In this case, me, Joe Barton, writer-director. And I don't even expect you to whistle respectfully at the sound of that name. For neither the producer or Joe Barton is known by many of our 20 million TV viewers. Anyway, at the moment, we had a new TV documentary on our minds. Subject, Army science. This one gave me a strange fluttery feeling, like a rookie ball player coming to bat in a big game. I guess it was because of the letter. I had received it just that morning.
I'll go see him right away. Okay, thanks, Pete. Joe, we're all set. You go around to some of these Army installations. Zero in on the people behind the sort of work we just saw.
Right.
You don't seem to be pepped up about this one.
Yeah. It'll work out.
That's what I like. Enthusiasm.
Enthusiasm? Who's against it? Not even TV writers. It wasn't the TV documentary we were preparing. It would come off okay. But what wasn't so okay was my present mood. And I guess some of it had spilled over onto the job. I reread my son's letter, the cause of it all. Especially those two sentences where he described graduation plans at his engineering college. Dad, he said,
I have finally made my decision on what I want to do after graduation. Hold on to your hat, Dad. I've accepted an engineering job with the Army.
I didn't have to read the rest. A job with the Army. That was surprising. And I had to admit, a little disappointing. My son had several offers from the best-known companies, and yet, well, it was his decision. Meanwhile, for the next few days, I had a lot of ground to cover. But I couldn't put it out of my mind. I was still thinking about my son's decision to take a civilian job with the Army as I neared my first destination the next day, the a military installation smack in the middle of resort country on the Jersey Shore, a little more than an hour's drive from New York. I kept asking myself as I drove through the post, what if my son were working here? What would he be doing? Would he have a chance to build a career? I had to brush back the questions, concentrate on my job, to look over the Army Signal Research and Development Laboratories at Fort Monmouth. First off, I have to admit a feeling of surprise. When my son's letter said he was going to take a civilian job with the Army, I guess I had a vision of barracks set in a bleak field, far away from any centers of activity. Well, my education began right here, in one of the best equipped laboratories in the world. Men of science were attacking a variety of complex problems, ranging from those which only remotely affect the combat soldier, down to practical items which concern him directly and immediately. In my TV work, I had been exposed before to the science side of the modern Army. For a previous documentary, I had covered the story of the first American satellite, Explorer 1. I would never forget the moment that great Roman candle took off. The memory of that moment was with me as I began to size up the Signal Corps' role in the space exploration picture. I went out to see Diana, the most powerful radar set in the United States. But I wanted to focus not on facilities, but on people, young people. I was anxious to see what the Army's attitude was toward the younger employee. That the Army got value from him was obvious. But what about the other side of the coin? Bluntly put, what did the Army give? My second day at Monmouth, I began to get an answer to my question. I witnessed a meeting held to discuss the results of an appraisal session involving a young engineer. Frequent appraisals of an Army technical employee lead to the development of an individual career plan, a kind of roadmap of his career. Present at the meeting were the head of the department, the employee's direct supervisor, the training officer for the installation, and the scientist or engineer concerned, who's not there as a spectator, but as an active participant in the development of his own career plan.
George, that sort of sums up the conclusions of the appraisal group that met yesterday. Everybody seems to agree that your career development so far is up to your real ability. Right, Bill?
That's right. Mainly because you took advantage of our training program, both on the job and in the related university course we arranged for you.
What it all adds up to is this. You're prepared for greater responsibility. Anything you want to say at this point, Dr. Collins?
Yes, there is. George, I'll spare you a lot of talk about this being a fork in the road. But you know, that's exactly what you do face right now. You have a choice. You can go on with some additional responsibilities on the contract projects you're involved in, or you might want to go into research and development. Now, the first will involve more management duties. Wouldn't you say so, Andy?
I think on the whole, yes.
That's right.
Well, George, how do you feel about it?
Well, naturally, I've been thinking about this for some time. I've pretty much decided I'd like to get in on the research and development end of our work, especially if I can qualify for the additional courses offered by the university.
Well, I can't see any reason why not. We'll see that you get the training you need in connection with your civilian career in the Army.
I agree that R&D should be the next assignment.
Good. Now, we have a spot that will be vacant next month in the engineering lab in the next grade.
I later discovered meetings like this one are typical. It made me a lot happier about my son's decision. When in May 1953, the first atomic shell ever shot from a conventional artillery gun erupted on the wastes of Frenchman's Flat, Nevada, it marked a significant achievement for civilian scientists and engineers employed by the Army, especially a group at an Army Ordnance Technical Center I visited in northern New Jersey. Again, my first impression was of modern, superbly equipped laboratories and buildings. I was shown through the installation by a man who had a lot to do with the development of the atomic shell. We were on the site of the centrifuge, a testing mechanism for missile components which whirls them around in a simulated ride through space. When the thought struck me, one of the most interesting things to me about the development of the atomic shell was that it was done by a team headed by an engineer aged, how old were you, Bob?
29.
In layman terms, how would you describe the basic problem?
Well, squeezing nuclear material into a shell of 11 inches in diameter and still have its delicate watch-like mechanism function when subjected to a million-pound blow when fired from a cannon.
Would you say it was unusual for so enormous a responsibility to be given to so young an engineer?
I don't know how unusual it was. I think that's usual.
I see.
The important thing is this: more so than any other agency using technical people, I have found that the Army is oriented toward young scientists and engineers and is prepared to move them on fast.
You might say the education of Joe Barton was moving right along fast as well. A picture was taking shape. Army science, a combination of young, ambitious, go-ahead men, the best of facilities, the warm, rewarding glow of achievement. One thing more. Throughout my tour of Army technical and scientific bases, I was impressed with their natural beauty and recreational opportunities. Picatinny Ordnance Arsenal, for example, embraces nearly 5,000 acres of wooden, hilly, bracing-aired countryside. Every effort is made to allow civilian employees to enjoy the natural splendor. But nothing obscures the only reason for an installation's existence: the job. A few days later, at a Chemical Corps post in Maryland, a masked supervisor led me through the ultraviolet airlock into a room housing an Army-developed bacteriological safety cabinet. The particular point that impressed me was the all-out effort to ensure the safety of everybody on the job. I noticed these men who were doing research into the transmission of respiratory infectious disease were using long rubber gloves extending inside the airtight cabinet. The researcher is able to manipulate objects within the cabinet and yet is not exposed to any danger of infection. How would I feel if my own son was wearing one of these masks? I'd want standards of safety to be the highest, which is precisely what the Army standards are. Scientifically speaking, the Army can't afford to sit back and wait for others to develop techniques. It must itself pave the way, and, especially at an installation like the Army Chemical Center at Edgewood, Maryland, one sees more examples of the Army in the vanguard of science and technology. I found myself in a laboratory where the problem of shellfish poison was being looked into. At work on the problem was a chemist only a few years older than my own son. He was trying to develop a color test. A simple identification procedure is a must if the number of accidental seafood poisonings is to be kept at the absolute minimum. I was still looking on when his supervisor walked in.
John, how are you coming along?
Not too badly, Dr. Simmons. I think we have several methods here that look promising. This one here is a test using gallic acid and sulfuric acid. 10 micrograms really gives a deep blue color.
How about impurities? Do they give the color also?
I've been trying to separate them in order to find out. Here, let me show you. These filter paper strips have been dipped into a solution of impure poison. The solution slowly travels up the filter paper. We spray the filter paper to get color reactions. We can't use the sulfuric acid system because the sulfuric acid reacts with the filter paper. Instead, we spray with trinitrofluorinol.
The sulfuric acid, gallic acid method is so much more sensitive.
You know, I've been thinking of using fiberglass instead of filter paper.
Sounds like a good idea, John. Let's try it.
Sounds like a good idea, John. Let's try it. At all technical centers I visited, I heard a version of these words often. Whether a chemistry laboratory, a construction engineering problem involving work in the field, a static firing test, or figuring out some small improvement in a countdown procedure. Day into night, around the clock, the thinking continues. The work goes on for the Army science team. The thrust toward knowledge of the world about us is no man's private property. A young man fresh from school may have something to offer, and the same young man has a matchless opportunity to learn from the very best in his chosen specialty. The Waterways Experiment Station at Vicksburg, Mississippi, the next stop on the voyage of Joe Barton, is just one of the many technical centers where engineers come to grips with the problems posed by the development of modern warfare. Problem: the blast of jet planes tears and buckles the surface of airstrips. A road to the solution. Studies of the resistance of various surfaces to jet blast. The work in pavement design is allied to other extensive programs, as for example, the design and testing of prefabricated landing mats for use in combat areas. Analysis of the ability of natural terrain to support off-road movements of military vehicles demands top technical talent. But at Vicksburg, another point was re-emphasized that I had not realized clearly when I'd received my son's letter. The contributions to our civilian welfare in time of peace. In the field of hydraulics engineering alone, the science of water in motion, Army studies have resulted in improved methods of flood control, conservation of water resources, safer harbors, and waterways. In a large building at the experiment station, I was surprised to come upon a model of New York Harbor. One of the major problems of navigational channels is shoaling, the accumulation of silt and other materials which impede water traffic. In the Vicksburg tank, a special chemical substance simulates the underwater matter. The patterns of its formation, since they duplicate actual shoaling conditions, help engineers in their job of maintaining navigable harbors. The qualified hydraulics engineer can see problems develop here a lot better than he can in a skin diver's rig. Here he brings into play not only his own specialty, but analytical chemistry, physics, geology. For science missions no longer could be restricted within one narrow area. He is encouraged to range freely into other specialties, if it will help do the job. Yes, east side, west side, all round the town. There's water, and how it flows and affects the New York Harbor is a core of engineers' responsibility. Back in New York, I watched the Essayons, an Army engineer dredging ship in action. Maintenance of about 300 coastal harbors is a mammoth job. Leaving the ship, I had one more call to make not far from the city before leaving on the final leg of my trip. That afternoon, at the United States Military Academy at West Point, I attended the Army Science Conference. one of the most important meetings of the scientific community held during the year. At meetings like these, Army civilian scientists and engineers keep abreast of the swift-moving developments within their specialties and have a chance to talk shop with their contemporaries in industry and the universities. Many of the new developments brought before this conference were reports on Army projects. It pleased me to observe the respect given Army technical people. Someday soon, my son's name would be on an identification card at such a conference. It was a nice feeling to sense the prestige the Army accomplishments have earned for its civilian employees. Early the next morning, I was in Natick, Massachusetts, a complex of gleaming new laboratory buildings near Boston, where I paid a call on the headquarters of the Quartermaster Research and Engineering Command. A young co-op student, about the age of my own boy, showed me around. There were many interesting things to see. The solar furnace, for example. It is a scientific instrument which concentrates radiation from the sun and focuses the concentrated energy into an image about 4 inches in diameter. The purpose is to aid in developing materials affording protection to the soldier against the occurrence of burns. I was very impressed by the knowledge and